Stalled. 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 Stalled.
In late December of 2014, an AirAsia Airbus A320 vanished from the radar screens over the Java Sea in Indonesia. Let's find out what happened. Welcome to Airspace. In the early morning hours of December 28th in 2014, AirAsia Flight 8501 departed from Juanda, the third busiest airport of Indonesia, towards Singapore. It was a normal flight until 11 minutes after the Airbus A320 reached its cruising altitude. At that moment, a master caution sounded in the cockpit, indicating that something was not quite right, but not dangerous. Master cautions usually indicate failures of a single redundancy or a failure of systems that are not that critical. In this case, the caution indicated a failure of the rudder travel limiting system. This system limits the angle at which the rudder can be deflected as speeds become greater during flight. The rudder is a very effective control surface, and if it were deflected fully during subsonic flight, this would be rather dangerous. At cruise level, the rudder is only deflected at a fraction of a degree, or single-digit degrees if an engine were to fail. Not much changes during normal flight with a failed rudder travel limiter system, since it's controlled by the autopilot anyways. The autopilot remains on if the rudder travel limiter fails and continues to control the rudder in a very precise and careful manner. Additionally, a procedure is displayed to the pilots which dictates that two flight control computers shall be reset, the so-called flight augmentation computers. These provide various functions, some of which use the rudder. Sometimes resetting these one by one can help to alleviate the problem with the rudder travel limiter. The pilots followed this procedure and the warning cleared. However, only 8 minutes later the warning reappeared. Again, the pilots performed the procedure and the warning disappeared. However, it kept coming back, and after 4 times the captain had enough. He got up and decided he would rectify the problem by pulling the circuit breakers of the flight augmentation computers, probably intending to provide a real and proper reset. But his idea failed spectacularly. When he pulled both circuit breakers simultaneously, the autopilot and the autothrust disconnected, and the rudder deflected 2 degrees to the left, inducing a roll to the left. 9 seconds after the autopilot disconnected, the first officer finally realized that the plane had reached a critical roll angle of 54 degrees to the left and corrected the roll with a brisk movement of the side stick. The plane rolled almost back to wings level, but the first officer also pulled the side stick back and rolled the plane back to the left. The stall warning activated for the first time.
Stalled. 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 Stalled.
Eventually, the first officer managed to get the wings level, but in the process continuously kept the side stick in a pulled position, lifting the nose of the aircraft more and more. It started climbing at an eye-watering speed of over 10,000 feet per minute and rapidly bled off speed and increased its angle of attack. The stall warning came on once again, and after the A320 had climbed more than 5,000 feet in a matter of seconds, the Airbus started falling out of the sky. The captain shouted at the first officer that he should pull down, and level. These commands were ambiguous, but still the first officer should have known that he has to recover from the stall. To do so, he should have pushed the side stick forward, but he kept pulling back. The stall warning continued sounding. Finally, the captain returned to his seat and started applying timid nose-down inputs, but to no avail. Since the Airbus's flight control logic adds side stick commands from the captain's and the first officer's controls together, these commands cancelled each other out. The aircraft finally reached an altitude at which it was wings level with the nose level with the horizon, a condition that would be normally perfectly flyable. However, the aircraft had practically no more forward speed, so the wings did not provide much lift anymore and the plane fell to the ground, like a leaf in the wind. It reached descent rates of over 14,000 feet per minute. Not even 3 minutes later, it hit the ocean below, shattering into many pieces. The wreckage sank to the ocean floor. Immediately after it became clear that the airliner had vanished, a search was initiated. Over the next few days, more than 90 vessels and search aircraft joined the multinational operation, consisting of Indonesian, Singaporean, Malaysian, Australian, South Korean, Japanese, Chinese, Russian, and even US equipment. First fragments of the aircraft were quickly found, and after 2 days, a sonar scan revealed that the crashed airliner had settled on the seabed at a depth of about 30 meters. This rather shallow depth made the recovery easier than in other cases. By March 2015, 3 months after the crash, most large pieces were recovered and sent for analysis. The investigation tried to look at the big picture of the accident. Why did such a minor system failure escalate to a full-blown crash of an airliner? And how did that small system failure even happen? And why did the crew act in the way they did? To answer these questions, the team not only analyzed the wreckage, but also the technical logs of the aircraft. They found out that the rudder travel limiting system had failed on many occasions before the accident flight. Most of the time, these faults were cleared by technicians who simply reset the flight documentation computers on ground. However, the fault kept reappearing, but no closer maintenance investigation was launched. The captain himself had witnessed such a ground reset a few days prior to the accident. This reset involved pulling both circuit breakers of the flight documentation computers and proved to be effective the time the captain witnessed it. Maybe that was why he attempted to do this very reset on the accident flight. But if multiple computer resets could not fix the problem, it's rather obvious that the real cause for the reoccurring failure must lie elsewhere. The investigators eventually found the culprit for the warnings. The electronic circuit boards of both rudder travel limiter systems had cracked solder joints on them. These probably originated from repeated heating and cooling of the chips during normal operation. These small cracks were not discovered during regular maintenance inspections. In the end, these small imperfections caused the failure of the rudder travel limiting systems because they led to momentary electrical interruptions that the computers could not handle. Next, the committee analyzed the captain's actions. Why did he pull the circuit breakers of the flight documentation computers without being ordered to do so by a checklist? One might be inclined to say, hey, why not? Any computer benefits from a good reboot. But you'd be wrong in an airliner. Aircraft systems are rather complex, therefore Airbus has a published list of many permitted circuit breaker resets. Many of them are allowed on ground, but only very few are allowed to be done in flight. The reset of the flight documentation computer circuit breakers is not on that list. So why did the captain reset them anyways, leading to the disconnection of the autopilot? Most likely he had witnessed a few days ago that such a reset fixes the situation on ground, and therefore he attempted to do the same in flight, not considering the consequences of his actions. Lastly, the investigation attempted to understand why the first officer acted in the way he did, and why the A320 stalled. Normally, the high angle of attack protection should protect the aircraft from stalling, even when the pilot continues to pull back on the side stick. However, when the captain pulled both circuit breakers, not only did the autopilot disconnect, but the aircraft's flight control law also changed to alternate law. In this control mode, these protections are lost and the Airbus can stall. First, the first officer reacted correctly by pushing the nose downwards when the stall warning came on. But when the captain started shouting, pull down, a very ambiguous command, most likely stemming from language difficulties, the first officer started to pull back on the side stick and kept it pulled until the end of the recording. Meanwhile, the captain only undertook very timid attempts at recovering from the stall. He pushed the nose downwards, but insufficiently. He also never took control from the first officer, who clearly had frozen up. Both pilots were trained professionals who passed their regular checks without any problems. Why they did not apply the stall recovery procedure like they should have is beyond me, and probably beyond anyone. This procedure would have called for a very clear call-out about who's in control, in which the pilot flying calls out, I have control, and the other crew member acknowledges with, you have control. After that, it is very clear who flies the aircraft. Next, the pilot flying will push the nose down and maybe even reduce thrust a bit, resulting in a decrease of the angle of attack and the recovery from the stall. Moments later, thrust may be increased again and the flight path can be recovered, usually resulting in nothing more than a loss of a few thousand feet of altitude. In the end, this accident resembles that of Air France 447 very closely. The autopilot disconnects for some reason, in AirAsia's case because the captain pulled the circuit breakers, in the case of Air France 447 because the pitot tubes froze over. And then the situation escalates very quickly because the pilots mishandle the approach to the looming stall. When the plane eventually stalls, the first officer keeps pulling the side stick back, either due to bad training or due to other human performance aspects, while the other flight crew member makes timid attempts at recovering the aircraft without ever taking control. A very sad accident, indeed. I would have thought that the pilots of the world had learned their lessons from the mistakes of the crew of Air France 447, but sadly this seems not to be the case. I just hope that this sort of accident won't happen again. But I'm not too sure. Thank you very much for watching. I hope you found this week's video interesting. If you did, leave a like and subscribe for weekly aviation videos. Thanks also to everyone who bought me a coffee with the link in the description. I really do highly appreciate it. See you all in the next one.